Hey guys, welcome to part 2 of this video. In this part, we're actually going to go ahead and clone freeRTOS, clean freeRTOS, and then make some tasks. So let's get started with that. First and foremost, guys, we're going to need to go to GitHub or Bing or whatever you want to search for. So you're going to search for GitHub and then freeRTOS. It should be the first thing that pops up. So we'll go ahead and click on that. And you're going to want to go to the freeRTOS-kernel repo. And once you're there, let me go ahead and open this on the browser here. So you go to the freeRTOS kernel repo, and that's the one we're going to want to clone. So we can go ahead and copy that. I have a git bash here open. You know what? Let me make this bigger for you guys to see. Okie dokie. I'm in the directory folder of my project. So if you look here, here's my project. That's basically this, my STM32 F4 project. And here's the folder, and you should see freeRTOS will pop up there. So we'll press enter, and there it is. It popped up just right there, the freeRTOS kernel repo. We're going to have to go to the IDE, and as you can see, it's not here yet. We have to right click and press refresh, and there it is. All right, so we went ahead and we cloned. Okay, now let's clean it up. By clean it up, I mean we're simply going to remove the files that we don't need. So let's open up the folder, freeRTOS kernel. Let's go into the portable folder. And these are all the different compilers that support freeRTOS, that freeRTOS supports. We're just concerned with the GCC compiler, so we can go ahead and delete everything that is not GCC. However, we also need this folder right here, memmanage. In that folder is memmang. This is where the memory management algorithms live. Basically, all the dynamic memory allocation functions live in these. However, you have to choose just one of these, and then you have to delete the ones that you don't want to use. So we're going to use heap4 for this example, and I'll tell you guys later in a later video why we're using heap4. But go ahead and delete the other ones and just leave heap4 in the memman manager folder. So let's go back, and so we're going to leave that folder intact, or we're not going to delete it. So let's delete everything underneath it, micro C down to whiz C. Can delete that. We're going to delete Kyle and IAR. If you're using Kyle, then obviously don't delete it, but I'm using STM32 IDE, which uses GCC. So I'm going to go ahead and delete IAR and Kyle. And then I'm going to delete all these above compilers, and we'll delete that. Okay, so that's that. Now we're going to go into the GCC folder. And now we want to find, these are the actual port files, which tell RTOS what interrupts to use for your specific core, and even where to find these interrupts. So since I'm using an STM32 Nucleo F4, that F4 has a Cortex M4 with floating point, which is right here. I'm not sure if you guys can make out these letters. Let's see if I can make it bigger. ARM Cortex M4F. That's the core of my microcontroller. So that means I don't need anything else in this folder. So we're going to go ahead and delete everything except that. Obviously, if you're using something like a Cortex M3, like the blue pill, then you're going to want to use this folder, and obviously choose your microcontroller according to what you're using. So I'm using this, and I'm going to delete everything else. Okay, in here you have the port C and port macro files, and we're going to leave those there. And that should do it. Let's see, include, yep, that's fine. And that's all we're gonna need. So we can go ahead and close this folder now, or I'll just put it to the side in case we need to come back to it. If you go here to your Cube IDE and you open up the freeRTOS kernel, you'll see that in the portable, all those files still exist, and it's because we have to do right click and refresh. So right click on your project name and refresh, and then you see there that this is cleaned up now. And just like before, even though this folder lives here, your IDE doesn't really know that it should search these folders for include and header files. So let's go ahead and do that. So we'll right click on the project name. We'll go to properties. Again, go to C++ general. We'll go to path and symbols. And let's make this. Okay, so path and symbols. And then we'll go to add a folder. We'll go to our include first. Include. We'll add a folder. It's in the workspace path. So we'll check that and workspace path again, and we'll navigate to the include folder for freeRTOS. Now, the include folder is where it looks for header files. So obviously we'll click on the include folder. Don't click or highlight the files themselves. Just click the directory. So that's where it's going to look for header files. Press OK. However, I'm going to show you guys here again. This is the let's go back. freeRTOS kernel. Obviously our includes are here. However, there is actually also an include file in GCC folder rmcm4. This right here is a header file. So we actually also have to point it to that rmcm4f folder. So let's add another folder under the includes tab, and we're going to include that folder where there is also a header file. So we'll navigate to freeRTOS kernel, open that up, portable, GCC, rmcm4f, and we'll just highlight the directory. Okay, and okay. And then we'll go to the source location, and same sort of thing. We'll add all the folders where there are C files. So if you go to portable, GCC, rmcm4f, there's a C file in there. Then we'll do it again, and we'll go to where am I at? Portable. There's a C file in mang, so we're there. And freeRTOS has a bunch of C files, timers, tasks, queues, lists in the actual root directory, which is just the freeRTOS kernel directory. So we'll add that folder. Right there, you can just select the main folder, freeRTOS kernel, and it'll include that folder. And you press apply and apply and close, and there we are. Okay, now I'm gonna switch to VS Code, which is open to the same directory. Where is it? There you are, big guy. Okay, so now we'll go to main.app.h, and actually I do have all of this, well, some of this. Let's go ahead and include freeRTOS freeRTOS.h, and I think we need to include, hold on one second guys, let me look at my other projects. We'll include tasks, timers, and semaphores, even though we're not necessarily we're not using that right now, but we will in the future, so let's just include them. We don't necessarily need timers or semaphores at the moment, but we'll include it. What else? And then we can go into our main app and start making some tasks and whatnot. I'm gonna hit save on this. I'm gonna go to Cube IDE and try to compile the project, and let's see how that goes. Hopefully I get common errors that you guys will get too, and we'll see how we can tackle them. First error it's giving me here is if I can scroll here, freeRTOS config. Oh, perfect. Yes. So we actually need a configuration file, a config.h file. The RTOS always looks for this file, and this is the only file you should be editing in order to configure anything with freeRTOS. And that file is not included in the RTOS kernel sources, because obviously it's just that, it's just a kernel source. So let's go back to where we were. Let's open this up again. Go back to GitHub, go back to the freeRTOS repo, and don't go to the kernel repo. Go to like the main page for freeRTOS, and go to the repo that just says freeRTOS. Click on that. In there, you're gonna find freeRTOS Plus, which is a whole bunch of Amazon related things, I believe, or not. I'm not sure. Anyways, but then go to the freeRTOS folder. So go to the freeRTOS folder here, and go to the demo folder after that, demo. And in here, you're going to find what is closest related to the core that you're using. So I'm using a Core M4, and it's by ST. So I'm going to find something that's Core M4 by ST. It does not have to be the exact chip you're using at all. As long as it's the same core and it's at least the same series of microcontrollers, then you'll be okay. So as you can see here, Cortex M4F and then STM32F407. However, I'm using a 446RE, and so it's different, but it's the same series, and the important part is that it's a Cortex M4. So I'm going to go ahead and open this folder, and what I'm really after is this freeRTOS config.h file. There's no need to rewrite this file, but we can do that in a future video, but it's just a bunch of defines and ones and zeros to see if you want that feature on or off. And freeRTOS does need this to run. So I'm going to highlight the name here, just copy that. I'm going to go to, maybe I'll go to here, we'll go to VS Code, and I'll include this in my main app include folder. So I'll just make a new file here, and I'll paste the name. There it is. Here I am. I'll hit save. We'll go back here. Let's go to the raw version of this file and just select all, copy, and come here, select all. Oops, no, not select all. Paste and save. So now I have that config file here. And just for sanity's sake, we'll go to Cube IDE, right click, hit refresh, and there it is. You don't have to actually include it anywhere. We hit project build, and you'll see that it doesn't ask us for that file anymore. So what's the next error that it's giving us? And again, I knew all these errors would pop up, and that's the good thing, because this is what I'm trying to teach you guys. So the next error is that it doesn't know what system core clock is. Where is this found? This is actually found in freeRTOS config.h, that file we just made. So let's go to, so here it is. Here's freeRTOS config.h. It's telling us it doesn't know what this is. Okay, fair enough. So if I go to, let's do that here in the IDE actually. So here I am in Cube IDE, and I'm looking at config.h file. If you hold control and click on system core clock, it will take you to its actual definition. So it does exist, right? And we know this for sure. So we're going to just highlight the name and the type, control copy. And then we can go back to the config.h file, the freeRTOS config file. And here we can just write extern, and that's it. Extern unsigned integer 32 system core clock. Now it knows that, hey, this is a variable that exists outside of your scope, and just believe me that it exists. That's all we're telling it. So now let's see what other errors we have. Next errors we are seeing is first defined. Anytime you see this first defined, that means you have something that's been defined more than once, and it's telling you where it's defined first. All right, so what is it? It's the SVC handler, the Panda SV handler, and the SysTick handler. Remember I told you that freeRTOS uses SysTick by default? Okay, so these three interrupt handlers is what freeRTOS uses, and most RTOS use to actually enable context switching to get the microcontroller into a privileged state, so then it can do the whole stack manipulation and do what it has to do to do context switching. So what we're going to do is we're going to go to the core folder of our project, our freeRTOS project. Let me switch back to, see, this is what I like it, because this is bigger. Even on my screen, cube ID icons and text are so small. So we're going to go to the core folder of our freeRTOS project generated by Cube, and we're going to go to source, and we're going to go to the f4it.c file. That is where Cube generates interrupt handlers. And what we have to do is basically comment out or delete those handlers, because freeRTOS actually already has these functions defined elsewhere. So we don't want them defined twice. There you go. Hit save. Go back to Cube. Let's build the project, and let's see what else it complains about. All right, now we have some other errors. Undefined reference to some v application tick hook. Cool. What does that mean? That means that there's some hook functions that it doesn't have. What does that mean? Well, these settings right here, and again, I'm in the freeRTOS config folder header file. So these settings right here that say something hook, that means it's expecting a hook function. That means you want to configure this hook or this tick hook, and you have to make a function for that, and you have to give it that name, the one that it gave us that it's not finding. In other words, v application tick hook. So we haven't defined any function with that name because we're not using it right now. So that's why it can't find it. However, we're telling it right here that we are using it, but we're not. So we should put a 0 there. Anywhere you see hook, put a 0, because we're not using that right now. So it should not look for those functions, which don't even exist because we're not using them. And this other one here, check for stack overflow, because this will also require a hook function. So idle hook, tick hook, stack overflow hook, set them to 0. Hit save on that config file and try to build again. Build project. 0 errors, 3 warnings. Let's get rid of these warnings. What the hell is it? Blink LED is not used. Okay, so let's use it somewhere. There's nothing nicer than just seeing 0 things here. Let's blink LED. Okay, actually I need to make macros for these. I mean prototypes. What else do I have? Print message. Needs a prototype. Okay. Go back here. Project. Build project. 0 errors and 0 warnings. Okay, so now that we have that stuff done, we've cleaned the RTOS. Now let's go ahead and make some tasks, right? All right. So let's go back to to VS Code. So I'm in my main app.c, and let's get this thing working. So first thing we're gonna do is let's make 2 tasks. Let's make one task to blink an LED and one task that will print hello to the screen. And we'll actually print something from each task so that we can see in the monitor, in the COM port monitor, that we're in each task. So I'm going to go ahead and I'm actually going to copy and paste again. So in my main app, outside of my while loop, I'm going to go ahead and paste this. Let's make this an integer at status. Okay. So we're calling this function. It's called xTaskCreate. As a matter of fact, let me pause the video and pull up some documentation for you guys. Okay, guys, I went ahead and I went to the freeRTOS website, and I just googled the function name, and it pulled up the documentation. I do recommend that you go to the freeRTOS freeRTOS website and download their user manual. They also have a great sort of PDF book on freeRTOS, so to speak, and it's free. So I really do recommend that. So here's the xTaskCreate function. What does it take? The first thing it takes, obviously, is a name to the task. As you can see here, it's a pointer to the task entry function. So this is an LED task, so I have to actually make that function, and the function has to have a certain prototype. So I'll show you right now. So here's LED task. It has to take a void pointer. Obviously you can call it whatever, but for consistency, we'll call it PV parameters. That is just a you will see right here. It's a value that you can pass to the task. So when you're creating, you can pass a value to this task via the, what is it? The 1, 2, 3, 4. Via this pointer right here. So you can pass it some data. Just how you can pass parameter to any data or any other function. You can pass value to this task, and there it is. Okay, so this task, once it gets initialized, it's gonna run through here, and then it's gonna be stuck in this while loop, right? That's how task or threads operate. So this parameter only gets passed once this task is called. Do not confuse yourself in thinking that here's an LED task and that this function is always going to be called. No, this function gets called once, and this while loop is what iterates many times. So you're not going to be passing this parameter, every single time your task runs. That's not the right way to think about it. Okay, the next, so the first parameter, you're going to give it the actual function name. The next parameter is just a name that can be used as a to reference this task. If you need to get the handle for it, for example, if you want to delete the task, pause the task, or restart the task, etc., you can get the name, its handle via the name, or you can actually pass a pointer here which will return the handle to the task. The next thing we're going to give it is the task stack size. Task stack size. I've configured this to be config minimal stack size, which is actually a macro. So if you right click on that and hold, if you control and click, it'll show you that it's defined in that freeRTOS config file, and it's telling me that the minimum configuration stack size is 130 words. These are words, not bytes, so it's 130 words per stack. That's the minimum that you can use. You can definitely use more. You can really use less if you want to, though you probably shouldn't. Next thing is the parameters that I told you that you can pass it here. The next thing here is the priority of the task. This is also defined in that, actually this might be defined somewhere else because it can't find it. Wait a minute, where is ID? What I'm gonna just, here's main.c, right click on this because I want to see where it's defined. Okay, it's defined in task.h, and it's 0, so we're giving it the idle priority, which is the lowest priority. Okay, and then the last one I told you, it's a pointer that will get you the handle of the actual task that was created. And this function will return a -1 if it failed. So here's, I'm saying if status is equal to -1, then we can print that there was an error creating the LED task. This was actually from before. Actually, no, we'll leave this here. Let me just move it up. Okay, so that's task 1. And then let's go ahead and make let's just call it hello task, and it's gonna be basically the same thing, but again, I've already typed this stuff, so I'm just gonna print it. So it's the same sort of thing. I have to give it the function name, which again I'm going to copy, so I'll just paste it under this. So I just gave it the function name and just some sort of name here. Oh, another thing to keep in mind, this name that you give your tasks, there is a macro here. Where is it? Let me see. Is it here or is it? Okay, here. Config max task name. It's set to 10. So don't make your task name have more than 10 characters. Okay, so keep that in mind. You'll get some kind of overflow, and it probably won't give you an error, but you will probably find weird behavior going on. Same priority, same stack size, and same priority and everything. So everything's the same between these two tasks. And then obviously the last function we call is to start the scheduler. And interestingly enough, this should never return, because once you start the scheduler, your tasks will have, their own time to run, and they both have infinite loops, so you should never return after you start the scheduler unless there's something wrong. So this right here will never get encountered. I'm gonna hit save. I'm not sure if I'm perhaps missing something. I hope not. And let's go back to Cube IDE and try to compile and see if this thing builds. Build project. Ooh, 3 errors. I love it. Hello, Ted. Oh, okay. So I've given the threads these function names, but C is sequential, so if you go from top to bottom, it doesn't know that this thing exists because this thing exists after it. So that just means I need prototypes. Again, hit save, try to compile, try to build, build for me. 3 errors. Okay, so let's see what's going on now. Malik failed hook, port v Malik. Why are you giving me that error? All errors terminated with build might be incomplete. I did point it to the, what did it say? It's undefined reference to, did I save the configurations here? Oops. Idle hook, that hook is done. Oh, here, Malik failed hook. And 0 errors, 0 warnings. If we go back to our main application, let's see what we should expect. That it's going to go to the hello task and print hello, and it's going to print a number. And then we're going to go, and then in the LED task, it will print LED, and that's it. So we should see kind of both tasks alternating in the terminal, and that's how we know we're actually executing both tasks. So let's see. Ideally, this is much better viewed if you have like 2 LEDs and one is blinking at one frequency and the other is blinking at another frequency. That way you can see both of them blinking at their own frequency at the exact same time. And that's really what the RTOS does. It gives you that sense of concurrency, that things are happening at the same time, when in reality, it's just giving every task its own little time slice. So let's go ahead and see if we can run this. I should be able to see it here in the terminal. No ST link. Oh, I forgot my device is unplugged. Hold on, guys. Okay, let's try that again. I think the previous application should still be running. Let's do that. Press OK. And okay, yeah, it's still running. That's from the previous video. Let's hit run. Clear this terminal. Hello LED. Yeah, it's going. There it is. So hello 1, 2, 3, and then LED and whatever. So it's going back and forth between the tasks. Where's my main app? Oops. Main app is here, and as you can see, it'll print LED hello. They each have different. I should have explained the actual task functions. They each have a different delay. So hello is delaying for 1 second, and LED task. Wow, loud car in my neighborhood. And then LED task is holding for 500 milliseconds, while hello task is for 1000 milliseconds. That's why you see hello and then you see LED happen twice. So yeah, guys, that is the basics of getting freeRTOS up and going from scratch, straight from the repo. You know what files you need, what files you don't, And again, we're not even using timers or semaphores, so we can actually remove that. The project will still build and everything will still work just fine. You only need your freeRTOS, the core files that are in there, and then you start including the things that you need. Right now we're only using tasks, and that's all the RTOS needs, and it'll do its thing. And then we can click that. Yay. All right, guys, I hope you enjoyed the video. Don't forget to subscribe, thumbs up, and I'll remind you guys again, check out the Discord channel that I've made. If you want to ask questions, it's better if you do it there, just because I can probably get to that faster than YouTube, and it's friendlier for conversations. So we can start our own thread for a specific question, for example. So enjoy, guys. Till next time.